So remember where we left off in the last slide, the last video. We were mentioning that there are certain areas where you expect to see star formation. Basically, where you see a lot of bluish light in reflection nebula and also some illuminated nebula, which would be the ionization nebula. And we found that when you look at the Milky Way, we don't see any of this, no perspective locations of star formation in the halo of the Milky Way. We see a lot of evidence of it in the disk. So this is where stars are forming in the Milky Way galaxy, and notice how the locations of star formation tends to have itself aligned, or actually seems to define the spiral arms of the galaxy. So it's not only happening in the disk of the galaxy, but within the spiral arms. So that's really sort of what gives them that appearance, is that's where the way the stars are taking place. What happens is essentially the spiral arms are places where gas gets sort of compressed, and the gas builds up, the clouds get the density that are required for the star formation to begin. And it's as this gas is compressed, this triggers the star formation, and then eventually what happens is, as the stars are moving through, as the things are moving through the spiral arms, you actually see young stars emerge from the spiral arms. It's kind of interesting when you think about it. The spiral arms, you might think are rather stagnant, but they're really sort of areas of like stellar traffic jams. Similar to what we see here is, these cars are all moving along, but there's this area where the cars are all just sort of backed up. The cars aren't going to stay aligned like this. Eventually cars are going to sort of free themselves from this little traffic jam and continue on. And exactly the same thing is happening in the spiral arms of the galaxy where stars are forming. The clouds are sort of moving into this area, but this is just sort of what we call a compression wave, or a region of high density where things slow down. The gas gets compressed, stars form, and then they end up emerging from that area. So the spiral arms are not a stagnant feature where stars are kind of moving in this sort of very fancy way, but it's just an area where stars are getting backed up, and then star formation is happening in that area. So let's think more about the galaxy's history and think about the halo stars. Halo stars are kind of interesting because they are made up of material that has very little old elements. And what that tells us is that these were formed in early stages of our universe because in the very beginning of the universe, basically the only materials that were present were hydrogen and helium. Remember, that's why hydrogen and helium are still the most abundant materials in our universe, because of the fact that they were originally the only materials. And also remember that the way that we create heavier elements like oxygen, silicon, carbon, iron, is through the nuclear fusion that takes place within stars and then is dispersed when they explode. So the fact that the halo stars have very, very small concentrations of heavy elements tell us that they're very old and were made very early in the history of our universe. The disk stars are more representative of the concentrations in our universe we see today, where they're about 98% hydrogen and helium and 2% heavy elements. And so this tells us that the stars in the disk are considerably younger than the stars that are found in the halo. So basically, what we're saying is that the halo stars formed first and then stopped, and the disk stars formed later and they kept forming. And so if we think about how our galaxy may have formed, we want to explain these two populations of stars. And basically, we believe that in a way our galaxy formation story is very similar to the formation of our solar system. We start with a giant cloud of gas that you see right here, and something causes that cloud to collapse under gravity, so it's disturbed in some way that triggers the beginning of a collapse. And as it collapses, there's going to be regions where the density is higher, and this is then when the halo stars are forming. Because it's very early on, there's no sort of definite motion in the cloud of gas, and that's why the halo stars have no definite pattern to their motion as we observe them today. Finally, the material that remains begins to contract into a spinning disk, similarly to what happened with our solar system. And see, here are the halo stars. They just sort of stay where they are. And then eventually you have what appears to be how the galaxy appears as it is now. So from that disk of material, stars begin to form, and then it starts to look more like the galaxy that we're familiar with. This is a pretty simple model, but it's sort of a nice general overview for how our galaxy may have formed. In detailed studies, they find that halo stars formed in clumps and then they merged together, but that's sort of extra information. Finally, let's take a look at what might be at the center of our galaxy. You might be surprised when you hear, when we look at the center of our galaxy in different wavelengths, we get some signals about what might be going on. There's some infrared light. There's also some radio emissions from the center of our galaxy. And we also see that gases are swirling around the center of our galaxy. Basically what's happening is that we're seeing signs of a very strong gravitational force or concentration at the center of our galaxy. And the evidence for this is the motion of the stars near the center. They're moving very fast. And also the emissions of certain types of electromagnetic radiation or different wavelengths of light is a signal that there is some acceleration of gases towards the center. And basically what this is telling us is that there is something at the center of the galaxy that has a very, very large mass, but we don't see it. And basically what astronomers believe is what is located here is a supermassive black hole that has the equivalent of mass to about 4 million suns. And you might be surprised to learn that it does exist because it's not sucking everything up. Black holes don't do that, but it is probably found in the center of all galaxies are these supermassive black holes. As gases are being pulled into this black hole, sometimes you see flares in the X-ray region of the spectrum, which also is a signal of the black hole. And that's it for now.